All right, everybody, we're ready to put it together for Chapter 8, Initiation Propagation, and actually you're going to learn about termination during this activity. Sounds appropriate. We're going to finish with termination, huh? A is the most deceptively difficult 1 point all semester. To answer A, there's actually 3 parts that you have to do in order. First part narrows it down to 4 boxes. Gets rid of half the box. You ready? No, that's later. Later. First step is, here's the steps for A. Steps for A. For A. 1. Eliminate half the choices that have slower formation of HX. What the heck does that mean? HCl or HBr, which one forms slower, because that won't happen. No. You're pointing, I'm sorry, looks like I'm being mean, but he's pointing at the periodic table. Wrong table. You need the bond association energy table, and the one that's less negative when it makes a new bond is the slower one. Don't pick any of those choices. All right. Which HX, was it Cl and Br we were comparing? Which one is slower? -368 is slower than -431. Why is he saying negative? We're forming HX. New bonds make electrons more stable, makes a negative delta H.
Professor, if you look at the numbers, how they're going, the F is 569. I can't see them clearly. But then after the F, the Cl is 400.
-431 here.
Yeah, and then it's going up as we go down.
Yes, there is a trend. Yes, on the periodic table. Yes. But this is like definitive numbers.
100%.
Yeah, we love that. So I'm going to write down -431 is faster than -368. I'll just write it on the first one. -4, oh, it should be black. -431, -368, bye. That's not bad, huh? 2 in blue. Which CH breaks first? I'm going to put them in blue. Some of the products have this H missing. Some of the products have what other H missing? Now, before you make an assumption that an H is missing from here, think again. There's one H on that carbon. There's one H on the same carbon. No. Where is the H removed to get to this product as well? The same H you removed before. Because it has to go from CH3 to CH2 here, CH2 here. How the heck did the pi move? I'm going to remind you. Why are allylic radicals so unusually stable? They can undergo resonance, where the pi moves. Okay? And yeah, the pi is going to move. But this has the same H missing as this, so I can't, you're not choosing between these with number 2. But which H is missing down here? It's a different H. It's this one right here. Sorry, there. For the third product, this H is missing, and the fourth product, this H is missing. Do we agree? First two products, the top one. It's primary and it's also, no, you can never be primary and secondary. It's the top one is primary because it has one bond to C, sorry, we're here, one bond to C, but it's also special with another word. No, we already used the word. What makes blank radical so unusually stable? That's the answer to the previous question. Yes, resonance. What made those radicals? And I need the those. What are the name of those? No, I'm talking about a special group that we added to primary, secondary, and tertiary last day. Allylic, and what was the other word? Benzylic. Please learn them. They're in the notes. The notes in the ninth section, actually, I've put the word benzylic down. You might want to use that one, because those are concepts that are very important. The resonance is coming up on this activity. Okay? So, first two products here, primary allylic. Secondary allylic for this next one down here. Secondary normal. I need three numbers, and I'm going to like this number the best. But I need them. Go back 2 pages. Primary allylic was this one, plus 360. Why did he say plus? We're breaking it. And this color's blue. Secondary allylic here. Right below 360. 357. Which of those two breaks first? The less exothermic bond is, sorry, it's not exo. Yeah, what is this, plus 3? Yeah, which one is easier to get to? You have to put in energy to break both of them. Which one requires less energy because it's going to happen first? The second. So right now we've gotten rid of that, that, and that. Is that right? Yeah. Okay. Because the 360 is not breaking before the 357. And it's certainly, the 357 is breaking a lot before this. Hey, 402 sounds wrong. But I'm going to look anyway. Secondary, not allylic. 402, I don't know how I remembered that number. Secondary, not allylic. 402. So you're definitely. That's it. There's only one problem with your hypothesis. The exam doesn't exist yet. he said I remembered it because it's on the exam. And I haven't made up the exam. Okay, so we're getting rid of this guy. Ladies and gentlemen, I said there were 3 parts to this. 3 parts to question 1. We got it in 2. We got it in 2. There's other examples out there that you will find before review day. This is your task, where a third question must be asked, because we hadn't made our decision after questions 1 and 2. You will find them. Okay, it's the one that involved resonance. Okay, it didn't show up on this one. Okay, so we got it there. Find other videos. Find other. Oh, it shouldn't be in green. I circled it in green. Find a video or an example. Could be a video, could be old notes where the strength of CX being formed must be used. more negative equals faster equals major. But we didn't need it here. Okay? I told you, for 1 point, that's the most work you're ever going to do. So you might want a strategy of just blow that part off, pick a box. But please don't pick a box that has HBR in it. At least acknowledge you read my first sentence. Okay? Right? Good? Pick a box. I will grade your whole question based on that box. You will lose a point if you pick the wrong box. One point. Yes.
How I looked at it immediately when I seen this, I said this was easy. Because the VR was not terminal, but also the double bond was not terminal.
When you find the purple 3, it will be terminal. Your statement will now be moot. You're going to find an example where it ends up terminal. So it's not about terminal and internal. No, it's about bond strength. Yes.
Are these steps always in this order? Or
Yes. Must do 1 first. Must do 2 second. Must do 3 if needed third. Okay. And here we go. We're finally ready for a mechanism. We did some research. That's good. We got half our numbers already. Provide a mechanism for the initiation and 2 propagation steps. So B, init. You take your halogen. In this case, it's a mixed halogen. The brother of Stephen Urkel is Berkel. And we have heat. That's what the heat's for. And what does it do? That's a weak bond, by the way. Lone pair repulsion. What is the heat forced to happen? The break of the bond in a special way, with the hooks going evenly. Homolysis. Yes. Homolysis. So you get a BR dot.
You have to learn this mechanism.
Oh boy, yeah. It's the mechanism for the chapter. Okay. I don't care about BR dot 1 bit. Because in the next step, the halogen radical that's more reactive is going to pick up a hydrogen. And you know which one's more reactive because you did the research. HCl forms a lot faster because Cl radical is more reactive. Make sense? Yeah. So prop 1. That all people are created equal. That's a different problem. Cl dot's going to take the H from the correct position on this molecule here. Oh, wow. Sorry about that. There. I needed to see my circle in green. And the H is right there, isn't it? For the green circle, it's that H, right? The 357. And you do a hookup. This hook meets this hook. The other half of the hook forms a very stable allylic radical. We love allylic radicals.
Professor, I noticed we use the two-side arrow for 2 electrons. For 1 electron, we use half an
This is correct. Yes. He was reminding us that a hook is 1 electron. Look in the notes from last day. And an arrow is 2 electrons, which we knew from many days ago. So you got that now. So we made a carbon radical. We can calculate delta HP1 right now. That would be delta HP1. You don't have to do these things in order. What is it to break the CH bond? We already have it on the screen. Give me a number and a sign. Yeah. Yep. Now you made HCl. Give me a number and a sign as well. Yep. So I'm going to do the big minus the small in my head here. 1 minus a 7 gets a 4. 2 minus a 5 gets a 7. And that's it, negative. Units, please, because it's the final answer. Kilojoules per mole is on the table, I promise. It's exo. So maybe she's doing this already. Maybe she's doing this already. Don't look at me, look at the screen, but you can't, it's too small. Yeah, that'd be early. If this is the rate determining step. If it would be early. But I don't think it's the rate determining. I can't promise. But if my next one is more negative, then this is the rate determining step, right? If the next one's more positive than this, then forget about prop 1. It's prop 2 study time. Because we only focus on rate determining steps, because that's the one you need to improve to make the reaction work better, right? Okay, so prop 2, you take the radical from prop 1, the one you made, and react it with a non-radical. Wait, these words are starting to sound familiar. I'm going to flip it so the radical's on the right side. And I'm going to put ClCl, a BrCl. There's no ClCl. BrCl. You're saying, wait, stop. You've used BrCl already. Stop. You can't use it again. Can you help that student through what I just said? Because it looks like I've already used up BrCl and I'm going to use it again. Yeah, I only used 1 or 2 BrCls in that first reaction. The initiation step, I used 1 or 2 out of a mole. That's 0, people. 0% of the BrCl has been used. None. The only reason you did the initiation step was to get the first chlorine radical, 1. And then that can do prop 1. And prop 2 creates the next chlorine radical for prop 1. After these guys hook up. Here's your Cl radical. Ready to go do prop 1 again. And the other thing is final organic molecule, the one you circled. Mission accomplished with your mechanism. And that was called prop 2. And we don't have the numbers for prop 2 yet. We have to do some research. So start thinking about categories for prop 2. This was prop 2. BrCl is a molecule by itself. And classify this bond here for me for CBr. I need the full classification or else I'm going to get the wrong number. Allylic. Well, I'm going to be in the bromine area, yes. But it's allylic and what? The category of the carbon. Secondary allylic is the only number that works. Secondary allylic carbon bonded to bromine. Bromine, right here. Primary allylic, right there. Secondary allylic, right here. Okay, so I need -228. I apologize if that didn't show up on the screen. I think it did. Yeah, we're on the same document. Sorry. Did I say -228? We're breaking this bond? Forming bonds in this universe makes electrons more stable. Remember, bond, electrons between atoms. Radical, electrons only near one atom. Which state do you prefer being in if you're an electron? I'd rather be in a bond because I'm more stable. Making this bond exothermic. -228. I hope that was the right number. A lot of discussion happened. I think it is. So, oh, BrCl, we never looked up. Circle, right in here, ClBr. Negative 219 or positive 219? Negative. No, it's positive. It's breaking it. Oh, okay. We said, so a student just said she's confused. Please stop. Breaking bonds is endothermic. Making bonds is exothermic. End of story of confusion. What are you doing to the BRCL bond in your mechanism? You're breaking it. What sign are you going to use? Positive, endothermic. If things are being held together, you got to yank on them for them to come apart. Yanking equals energy. You're putting energy in, right? All right. Are we still confused? No. Okay. Carbon bromine, we made, it's negative. So now it's 219 minus 228. So I got a bigger number second. So 8 minus 9 is a 9, and then the 2 became a 1. It's just 9, right? And it's positive or negative? Negative. Yeah. More negative is faster. I don't want to talk about faster reaction. In the question, it doesn't ask about faster, and it doesn't even use the word faster or slower in the question. Does the rate determining step, oh, wait, which is the rate determining propagation step? It doesn't say anything about fast and slow. Guys, the rate determining step is the slow step, period. That's what makes it the rate determining step. Okay, which of those two steps is less negative, because that's the slower one. Okay. Less negative, therefore, RDS. And you don't want to define rate determining step? Go to the top of the page. You say RDS is rate determining step. Just add it to my question right there. I just threw it up there. See? It's right there. RDS. Done it. I don't want to write those words anymore. Okay. Less negative. This is a fact every time. That is the fact every time. Please don't memorize 4 scenarios. What happens if they're both endothermic? What happens if one is endothermic and then one is exothermic? What happens if they're both exothermic? Why are you inventing stories? Less negative is the rate determining step. Because the more negative it is, the faster it is. It's in your notes. Got it? That, if you memorize it that way, you're memorizing one thing, and it's not like 3 scenarios that I just went through, right? If I had 2 endothermics, which one are you going to pick? For the slow one. So I have a hypothetical. I have a plus 11 and a plus 20. Which one's slower? Plus 20 is incredibly slow. Plus 11 is just slow. Okay? Just slow in this case is faster than incredibly slow, right? So you're having a problem because you didn't have a negative number. Okay, well, you got your scale. You got 0, 10, 20, negative 10, negative 20, and pretend it's like these are 5 situations, and I want to compare every one of them. A versus E. Which one's faster? Those are the answers for kilojoules per mole on the right. E. A versus D. D. Yeah, you're having no trouble when there's a negative every time, right? A versus C. C. It's going to be the second one every time you're comparing with A, right? Can I stop with the A's? You get the idea? Okay. How about A versus, we didn't do A versus B. I said I was going to not do it, but you're going to pick B. Why? They're both positive. Which one's closer to being negative? How's that? That's the faster one. Maybe you want to go with faster one every time and realize he's not asking about faster, he's asking about the other one. Does that work? We don't want any confusion.
You just said 11 and 20, and you said that 20 is slow.
Okay, now I changed it to 10 and 20. We're still in the same question, right? Which one's slower, the 10 or the 20?
The 20.
The 20 is slower,
Why did you circle me then?
because I circled the wrong answer in every one.
No, we picked the faster.
I'm picking the faster. Oh, I asked the question which was faster, which I never ask on tests. No, now you deserve to be confused, and I agree with you.
Wait,
Because I just changed the question from what I normally ask to the opposite. So when I change this to which is slower, I'm going to move every circle to the left. Which is slower, because Dr. Whitaker only asks about slower.
but A and E is.
A is the slowest of everything listed. Do you agree? Any number on the page right there, up there. A is the slowest. How about B versus D? Just throw one more in there. I got a positive and a negative. I always pick the negative, right? Slower though. Negative is faster. B. You can reword this. What? Sorry. People in the video don't know what I'm saying. I was pointing to, you can reword this as more positive is the rate determining step. What's the opposite of less? What's the opposite of negative? Two negatives? It's the same question. Okay. Do you like that wording better? More positive is the rate determining step. I'll just write it down, AKA more positive. If that's helping, but now you're memorizing two things, but you're not. Okay. Yeah. I think this is a good video break to transition to the next part of the question, okay? Since we're here though, we should do delta H reaction, that's right. We've got the two prop steps. We're gonna sneak in delta H reaction and then switch to a new video. You just take the numbers you see. Negative 8.3 kilojoules per mole. We never did our explanation either for why we said prop 2 is rate determining step. We should answer because that was part of that question. And your answer, you cannot skip the fact that you know about delta S. Some of you may have heard of delta S for the first time today. The only thing you're ever going to write about delta S, as in Samuel or silly, is what you're about to write down right now. In these reactions, this is still continuation of rate determining step, which was D, which started here and continues here. If you skip this, you just threw away a point. When delta S equals 0, if you don't write that down, you just threw away a point. Then delta G is roughly the same as saying delta H, because the equation says so. Delta G equals delta H minus T delta S. If delta S is 0, that's the equation. Delta G is delta H, sorry. I forgot the delta. You threw away another point if you didn't write that second part. And then you say, why'd my D move? That's a good question. Then you say, when delta S is 0, then delta G is roughly delta H. Therefore, prop 2 is RDS because it is less exothermic. Say all those things. Less spontaneous. And in our case, we're using spontaneous as a synonym for speed. So if you're more spontaneous, you're faster. You can only do that when comparing similar types of reactions, and that's what we are doing. You cannot always make that statement. I want to get this out of the way because that was just an exercise, right? Don't be putting that on your test. Okay, and then we're stopping our video. Picking it up.